18th through Friday, February 20th, I'll be implementing. On Wednesday, I'll be taking the treatment group in class and having them go through the Desmos inquiry learning activity. And the other treatment group is going to the library for that day. They're watching a video on a non-related lesson, and that will be day one. On Thursday, yes.
First, I'm going to record this, okay?
Oh, yes.
So I turned the recording on, and if you will agree, I would like to use this for future teaching purposes.
Absolutely.
Thumbs up. One of the things that I want to do is comment while you're talking about some of the things that you're talking about that are part of your experimental design for somebody who might watch this in the future. And so in this case, what you've got going is a randomized block design where, so what have you done? Have you randomly assigned students from each classroom to an experimental and a treatment group, right?
So of the 3 classes, I've taken them all and put them into the randomized block sampling. I didn't do it by period because each period has its own kind of hidden, variables that tie those students together. So I thought maybe I should do it that way, or do you think I should do it by period? And
actually, that's the purpose of the randomized block design, is to do it by period.
Okay.
So what ends up happening is, as you described, within each section you have, there are variables about the schedule that put certain kinds of students in that section. So when you randomize block design, within each section you randomly assign to the treatments.
Okay.
That way, that particular tier of students is randomly assigned between the treatments. That's where the block comes in.
Perfect. Okay, so they'll be split up that way. That makes it a lot easier.
So then, so you talked about sending them to the library. So what's happening is, in order to give you time to teach students in one class who are receiving 2 different treatments, you're having one group of students go to the library and work on another unit that's not the experiment, but that's something that you would do otherwise in your math curriculum.
Correct.
Okay, thank you.
You're welcome. So, cover day 1, then day 2, the groups will swap. And then I need your help on this. I just saw I might need 4 days because I wanted to have the students then have an in-class day where they practice using the treatment that, so for example, if students were in the group where they were using Desmos.com as inquiry based, then they would use Desmos for their homework. And then that would be done in class so I can monitor how long the students spend on the practice. And then, so I guess that would occur on a Friday. And then on Monday, students will take the post-assessment.
Okay. And have your students used Desmos prior to the experiment?
They have.
And so you've done that with all students, right? Your experimental and control group students, because they've all used Desmos for something.
Yeah, and it's been more that teacher-centered approach where I would have a answer key with a traditional kind of guided note sheet for like a more traditional learner, emailed to them to use as a study guide. But for the class, they didn't write down anything. Just we had a conversational piece while I would just play with the parameters, and then we would kind of dialogue about it. But this time I'm going to be removed from the equation as the deliverer of the content. They'll be constructing things on their own while I guide.
Okay.
So they've worked with Desmos and with other teachers as well, so they are familiar with the software. This is the first time they'll that one of the treatment groups will have a structured learning activity around Desmos.
Yep. Okay. So what we've done here, though, is you've eliminated any learning curve that's associated with using the software during the experiment.
Correct.
Okay. Great.
And so yeah, that pretty much sums it up. Have those 4 days.
Okay. Do you have your lesson plans worked out for your treatments yet?
I do.
Can you show me what you're going to have the students do?
Yeah.
Okay, so we can use screen sharing, and you can actually just...
Okay, so here is the learning activity. Let me know if that popped up for you.
Oh, that's great.
Okay, great. So this is for Group A, where there is a student-centered use of Desmos. It starts off with tying to prior knowledge, going from exponents to logarithms, since it's the inverse or the reflection over the line y equaling x. It starts to transition into the Desmos activity by talking about the parametric form of a common logarithm. Makes a couple notes, that the x and the f of x are the variables, but what they'll do is manipulate the parameters a, h, and k. That's what creates the family of graphs. Then it walks them, just kind of says, hey, here's Desmos, and then this is the link that's already set up. If you go to that Desmos page, then everything's already inputted. Now they just have to explore, so it takes that piece out of it for them, and it's
Can you
set
go ahead
up.
and open the page?
And on this web page file, I have put it into a table. So that's one form of it here. And then here are the sliders for the parameters. And then there's the graph.
Okay, that's interesting. The Desmos didn't pop up.
Okay, so on my share screen, I guess it's having me do it by window.
Yeah, I still have your lesson plan.
Okay, let's see here. Oh, I could just choose desktop, huh?
Yes.
Okay, perfect.
There you go.
Thank you. And then let me put this on presenter mode, projector mode. So this is what the document that students will be working with. So they could, part of the activity will be to identify the effects of A and B. So it says what happens to the graph when A is negative. So they'll go to Desmos, they'll make a negative A value, and they'll see that as soon as it goes negative, we're reflecting over the x-axis. And then they'll have a look at what happens when B is negative, play with that. They'll see that's a reflection over the y-axis. And so that's what the activity does. It leads them through. You notice I grouped A and B together. When I ran this through with my college prep students, so that my honors didn't see a lesson like this, I ran them through separately, like what are the effects of A? And then that was like 3 questions. And then I did it again for B. And it seemed that tying them together would be a nice evolution of the content, because once you figure out the one, it's kind of the same for the other, except just the different dimension.
Yeah, and I think it makes sense for the learner to construct them in pairs, to construct that meaning as a pair that A and B are working similarly, just flipping across X or Y.
Okay, great. I'm glad that seemed like the right call. Then we go into H and K. Those are going to be the ones that do the static translations. So this looks like it's kind of like bending it up towards some kind of asymptote. So getting these back to now, taking a look at here more of the standard graph, it's a little easier to see. it still kind of looks like bendy, but they're going to have to understand that what's actually happening, if they look at the table of values, is if I add 1, so we're starting at, say, 0.3 for the 2, and if I add 1 for the h, 3 for the 2, it moved horizontally to the right by 1. So I could see that here on the graph. Actually, the table now moved the vertical asymptote from x equaling 0 now over to here. And so then this is actually the x-intercept, which was at 1, 1, 1, 1 comma 0. And now with the horizontal translation to the right by 1, everything slid over by 1.
Okay. Okay.
And this will move things up and down. And that's the next section. Any questions up to there?
Okay, no, good.
Okay. And then part 3, and this is where I found that especially long-term, students struggled the most in retaining what happens when you have a horizontal stretch or compression or a reflection over the y-axis combined with a horizontal translation. So I specified parameter values where it's going to make it a horizontal translation to the right by 6 and a horizontal stretch by 2. And what they need to develop is that because of the horizontal stretch by 2, that'll actually make it look like a horizontal translation to the right by 12. The reason being is because, yes, the horizontal translation moves it to the right 6, but then that's followed up by a horizontal stretch by 2. So it doubles everything that is involving a change in the x direction.
So then for step 3 in these questions, they're going to have to synthesize in their own words the effects of these.
Yes. This is going to be an interesting part between the 2 treatments because I've been teaching this concept to students as a direct teaching method. And I've shown them algebraically how to rewrite it so that you could factor out the 2 from the 6. So my mistake, it'll look like a horizontal translation to the right by 3 because you factor out the 2 from the 6 and get.
Okay.
Yeah, okay. So I had that backwards. And that's still pretty difficult for students. So whichever method can send that knowledge, like that message home for students, that's going to be a huge gain. I'm really excited to see which one. Is it going to be the direct teaching method because it's very difficult of a concept, and does the teacher need to explain that? Or can students figure it out on their own using a simulation? It's going to be pretty exciting to see what happens with these results. But this is where, like, 1 out of however many students ran through my pilot last semester, like 1 student got like 1 of these 3 questions right. It was bad. So I'm pretty excited about this part here.
You know what you could do with part 3 there is add a 4th question where you presented the algebraic equation that you teach and ask them to explain why that works based on their answer to number 3.
That's a really good idea.
So again, the rationale for doing something like that would be to give multiple pathways into this schema for translation, to connect it as many different ways as possible.
That's excellent advice because I was still at the perspective of, I'm really just supposed to be a guide. I'm not supposed to kind of like give that to them, but I'm not. I'm just kind of nudging them along, I guess. But that's great, and tying it to the algebraic.
Mm-hmm.
Excellent.
Okay.
And then this starts to take the concept of what the parameters do and apply it as a skill. So we're looking here at graphing using transformations. This is similar to what the items on the post-test look like. And I break down for them the steps then to actually work with the parameters effects on the resulting graph. So I tell them that they have to translate the vertical asymptote and the x-intercept. Those are going to be the features of the graph that I look for to see if their sketch is correct. I did decide to remove the other point because the more that I reflected on how transformations work with logarithms and exponential functions, the curvature is less important, because if you're really going to need a precise graph, then you're going to use graphing technology anyway. So this, again, is just supposed to be a mental construct where they could visualize what the graph should look like close enough. So I made that judgment call, and then I tell them with the horizontal stretch or compression with the x-axis, how to do that, and then go ahead and make the sketch. So then there are 3 practice problems where students could use Desmos.com for this activity, and when we do it in class, students will not be using Desmos.com, because I, as the teacher, that was like more my tool.
Mm-hmm.
But
So,
depends on what you think on that. So what are your thoughts so far?
so they would take the equation then. So g of x is equal to 5 log x minus 2. So they would set the Desmos up to that equation, or would they start with just the standard equation?
So
translate it into that.
If the students feel confident, which most of them I think they'll see this as a vertical translation down by 2 and a vertical stretch by 5, and they'll probably get right underway. If they feel, oh, go ahead.
I'm just making sure I understand what they're doing. So the simplest form of the family, okay, no steps for graphing logarithms with is to translate, okay. Sketch the logarithm. So are you going to have them sketch the logarithm and check it with the Desmos?
Yes,
Okay.
or if they are stuck, they'll use the Desmos to unlock what happened, and then they'll copy the graph.
That's interesting.
Yeah, I'm thinking they'll probably need to do that for this example here, because this is the one where we're combining horizontal parameters.
You might make that explicit for them, to tell them to do that, if they get stuck, and have them see if they can reflect on why they're stuck. And then once they've simulated it with the Desmos, explain the resolution.
Okay. That sounds great. Okay. So I think this would take about 1 class period to have them go through, to answer their questions, to have them practice, to have them compare their work to Desmos, and to, again, answer any questions that they have. I think that would fit nicely in a 44-minute period.
Okay.
So this would be Group A's treatment.
And so the treatment's going to last 1 day, or?
Correct.
Will there be a second day where they practice or something? The second part of the treatment?
Yes, so I guess that's considered part of the treatment, perhaps.
If one group's going to practice with Desmos and one's going to practice with pencil and paper, is that what's happening?
So they'll have the same homework assignments to complete. Group A's students will be able to use Desmos.com to help them complete homework assignments as needed. The other group, I thought I would restrict their ability to use Desmos.com because it was more like a teacher tool.
Okay. So what you might ask them to do is just self-report on how much time they spend on the homework, just as an additional data point.
And it's going to, the homework will be performed in class. So
so you're controlling the homework then.
Yeah, we want it to, that was your suggestion. which was great because it allows us to control for that time variable that no one student is going to spend any more time than either treatment.
Okay. So is there the possibility that the students who are using the Desmos might actually be able to do more problems?
Correctly? Yeah. I think we should probably still have students report the number of problems and maybe the number of time that they spent using Desmos to help them get the answer, just so we could maybe calibrate its contribution.
Right. So do you assign a fixed number of problems, or are they just going to have a period to practice?
I'll bring that up for you. We have from the assignment sheet, this is using the textbook file for Chapter 7. And let me know if you want me to reshare any of this with you. I did so through a Google Drive link in an email I sent.
Okay.
And so this is the assignment for the treatment. And it says complete in class only. Please do not work ahead. That shouldn't be a problem. And so, yeah, these are the set problems then that both treatments will complete in class.
And if the Desmos gets more done, will there be some extra problems then for them to do? Or let me ask it differently. Do you think the Desmos group will be able to do more problems?
I don't think so. I think their accuracy may be a little better if that's what we mean by do more problems. I feel that by this time, students across the board are pretty confident in their understanding of the parameters. The big idea then is how they can translate that information to the context of logarithms specifically, where now you have this abstract idea of an asymptote that could be somewhat difficult. And because it's more than just a parabola of right one, up one, left one, up one, and the origin and modifying those. So that's one of the things that they have to battle with in terms of their concentration and understanding. And also I've had them go through the combination of horizontal transformations before, but they know now that like all bets are off. Like I'm going to give them the hardest possible combinations and no mercy on the test or quizzes. We started that a couple chapters ago and they started to deliver. But did I answer your question? I don't know.
Okay, just you have to use your judgment on how they'll use that time. But you just want to make sure that you look for differences in how they're doing their homework.
Okay.
So any information that you can gather about that might be useful just in explaining your results later.
Okay. Let's see. Perhaps I could have just on a separate sheet where it's not given to any students at all. Like once I see that students perhaps are finishing, because I think you're right. They'll probably finish early. Both groups would, and because they'll probably finish this in about a half an hour. I could say, okay, here's the board problems. If you need additional ones, look up here, continue to work, and then I could have every student email me their homework because it'll be all done on the iPad. And then I keep track of how their practice went, which treatment group had better accuracy, which treatment group was able to complete more problems successfully. Does that sound like a good idea?
Okay, so you'll collect their homework electronically then?
Yeah, so we could have record of that.
Great.
Excellent. That wasn't in my IRB application on collecting that information. What do you think should be done about that?
The part that you were going to collect their homework.
Yeah, that wasn't submitted.
How did you, on your informed consent form, what do you say to the students that you're going to collect? Oh, did Jody tell you then to go with a shorter consent form?
It was recommended, but I didn't change it up. I just kept it as it was.
Okay.
Yeah. All right, let's see here. I guess with the consent form, it doesn't specify what is going to be used, what kind of data. To use the materials and test results you create during these lessons, so it fits.
Okay. So then you're good.
That's excellent. Great. So that kind of talks about the one treatment where we have, sorry, I'm kind of like flipping all around here. Oh, that's why. So we talked about this, the practice problems in class from this textbook file laid out by the assignment sheet. Let's see here. This is the new version of the assessment. You'll find that it looks very similar to the first one. It had 6 questions before, and I felt that the original 6 had isometric pairing. However, because I was having more than one transformation in a single problem, if they messed up the one, it might have made it unclear to me if they got the other one correct. So especially for the harder ones, here we have a doubling of a horizontal compression by a half. And so then this is going to be a horizontal translation, excuse me, by 3. Here we're combining a reflection over the y-axis. And so this, after you factor out the -1, will also show that it's a horizontal stretch, rather a horizontal translation to the right by 5. So here we're combining some vertical transformations. And then down here, I have some more of those. So these are now direct isometric pairs where they are the same. They're testing the same exact thing.
Okay.
Except this one's like a minus as opposed to a plus. And this one here is a fraction as opposed to a whole number. So I felt that was where I really had to kind of scratch my head and be like, okay, did the student really have this one part of the problem right versus the other in the pilot assessment? And now it'll be very clear, if they get this one right and they get this one right, I feel that they'll be solid on it. Or if they get this one right, but then get this one wrong, it might just because when they factor out a 1/3 from a 1, they don't make it a 3 here. And so then that might be just like a understanding of fractions and rather than the transformations. And I could better make that call.
Okay. Oh, so because you're correcting these longhand, you'd actually be able to judge whether it was a transformation error or a factoring error.
Yes.
And you wouldn't count it against them. When you did the pilot assessment, your reliability came out really high, didn't it?
It did.
Yeah. Okay. So if it came out high for that, you should be good here.
Great. And I figured open-ended seemed to be the consensus to make for better results, like not better, but be able to understand the results better.
Right.
So instead of having like multiple choice and graphs from which they could choose, but have them like create it from scratch and then be able to see that work.
And you consider these all of these problems are fairly difficult.
I do, by virtue of the fact that it's transforming logarithms. And then once we get down to problems 3 and beyond, it's no longer basic. Just these are flip over the x-axis and translate to the right by 1, translate to the right by 3, translate up by 2. So these are just kind of warm-ups, which research shows that you want to give them confidence and get the momentum going. And
definitely.
Here, each of these separately, I would say is pretty basic, but it's a trio. Just wanted to throw that in there. This is also a trio, but now we're working with the doubling up of the horizontal. And then from there, it maintains the level of difficulty, especially on page 2.
And this does not count for a grade?
Correct. And I alerted students to that factor in the Q&A after reading the recruitment script. This will occur on day 4, and it's not part of their grade in any way.
Good.
A student asked me...
I mean, that way you can really give them a difficult test and they don't have to worry.
Yep. A student asked me, they're like, hey, if you find out that one of the treatments was better than the other, are you then going to reteach that content using the one treatment? It was cute, right?
Well, that's part of the issue with the grading too. So if you were actually using the grades, then if you find out one treatment's more effective, you have a built-in unfairness in the experiment that one group actually learned more than the other and got graded on it.
Yeah. So there is, separate from the research, the end of chapter 7 test. And it will have 2 problems. One will be like this one, where same directions and everything, they have to graph using the transformations. And the other one is graphing an exponential function using transformations. So on the one that's similar to this guy, number 6, yeah, maybe one group will be better than the other, but what I'll do is, like, I'll have the results tabulated before that, by the time we start reviewing for that chapter test. And on good faith for the students, I'll have a better idea of which one worked better. And let's say it was the direct teaching method. Let's say that one was better. Then I could go ahead on the review day for that content. I could replicate that like lesson in a miniature form, or vice versa. And I think that's a nice way to give the best service to all students.
Excellent.
Okay, great. I think that wraps up kind of the treatment. Now, one thing I really don't have planned yet, sorry, is the lesson for the second experimental treatment, because it's going to be a modification of kind of what I've already been doing. So if I bring up the old form here, it'll look like this second page here, but I'll just be going through this. Well, it's kind of weird. The treatment for part B, group B, is that conversational piece. They're really not going to write anything down until the very end, where we go and try a couple examples. So it'll really just be like 2 or 3 examples, and that'll be the lesson. But the most of it is just the conversation as I go through Desmos with them at the center, at the front of the classroom.
Mm-hmm. So you're explaining and demonstrating, and they can ask questions.
Correct. And then I have them apply in the end, and they'll be the same problems that the students will apply in the other treatment group.
And the examples that you use when you're explaining are the same examples that the students are working through on their own simulations.
Correct.
Good.
Yeah.
So everything is parallel except the delivery.
Correct.
Excellent. Everything's looking good.